Hi, my name is John and I'm a Unity developer. One of the things that I've been exploring recently is how to produce behavior in a group of actors that looks similar to what you would see in a flock of birds or a school of fish. Now, the most simple way to produce behavior like this would be to just take the distance from every actor to every other actor. But that would be very computationally expensive because that computation scales up with the square of the number of actors in our group. So we want to figure out a solution that produces similar behavior in nearby actors, but without having to compute distance from every actor to every other actor. So how do we do that? Well, there's a couple of components that in the solution that I've developed. First of all, what we really need to do is we need to take a rolling average of the positions of all of these actors. So for example, let's say that this is the center of mass of all of these actors. And then what we can do is we can draw separating planes that pass through that rolling average center of mass. And then for each separating plane, we're going to just ask a very simple question of each actor. Is that actor above or below that separating plane? And then what this does is it allows us to group together groups of actors by their separating planes rather than their distance from each other. So we can just assign actors who are above or below the same separating planes to have the same behavior rather than assigning actors who are close to each other to have the same behavior. So that cuts down on our computations a lot. But that just assigns these actors to head off in a certain direction, and then they'll all just split up and go their separate ways. So we need to figure out how to produce this swirling flocking behavior still. So there's another component. In addition to having a rolling average of the center and these separating planes, what we need to do is we need to also be constantly rotating these separating planes based upon the amount of the population that is headed in that certain direction, and always be rotating these separating planes in order to try to always be turning the separating planes against the current heading of the largest number of actors heading in that direction. And that may sound a little bit arcane, but don't worry about it because the implementation is actually very straightforward. Basically what we're doing is we're drawing a separating plane, for example here, and then we're saying that for every actor that's heading in that direction, just rotate the separating plane just a little bit in the exact opposite direction. And we're maintaining records of these separating planes as vector 3s, and these positions are already vector 3s, so the change that we have to apply in order to accomplish that is very straightforward. And that's what's going to produce this rotation or swirling that we see in this group of actors. So there's just one more component to produce this flocking behavior, and it's that if there's already actors that are very far from the center of mass, they may still be in the process of moving away from the center of mass. And so we just need a few more guarantees in order to drive them back toward the center of mass. So there's two components to that. First of all, if they're facing away from the center of mass and they're already very far from the center of mass, then we can just tell them to rotate faster. And statistically, that's likely to drive them back toward the center. The second thing is the further away they are from the center of mass, the faster we tell them to move. And the end result is that by the combination of that rotation of separating planes and by that faster rotation and faster movement when they're further from the center, this causes these actors to be statistically likely to just continuously be moving toward the center of mass and then outward and then back inward again. And this is what ultimately produces this sort of flocking behavior. And so you can see here we have, for example, the main body of the actors is here, moving around and rotating, but then there's also constant shifts in direction. There's always swirling, there's always separations and reformations. Here we just had a sort of separation there, and then they're consolidating again, figuring out a new direction to move in, going over here. And again, this is meant to simulate the behavior that's seen in, for example, flocks of birds or schools of fish. And by using these separating planes, we are able to save ourselves a lot of computation that would normally have to occur. So the code for this implementation is going to be uploaded to github.com/John A. Sharifi, and the implementation is actually very simple, and I encourage everybody to go check it out because I think that this is a really effective solution to this problem.